All right, Dan, how's it going? Here we go. We're going to now run the numbers that we did out in the shop there. So I'm going to load them up onto my computer. I think I'm having issues, so we'll see what happens. All righty. Go to my card, and that was 7510.CR2. That stands for Canon RAW. I don't know what the 2 is for. I don't care. And it's now right there. So I'm going to get rid of that guy. And now I got to go to my proprietary software to convert my Canon RAW into TIFF. And so I come down to 7510, which is that guy right there. I highlight it, convert and save. It's going to convert to an 8-bit TIFF. That's what we're after. Try this with 16-bit TIFF and it just all went to crap on me. All right. I now have that TIFF image right there. So we're going to open up ImageJ, wonderful little program, and I'm going to click this circle here, and I'll show you what that does later, but I do it now just to get it out of my brain. And I will open up that TIFF file that we just created. Image7510.tiff. And it looks just like that. Now, Lonnie likes to do this despeckle. I don't think Bill does. I do it, I don't know. I don't think it matters. Go to Analyze, Set Measurements. You want to have center of mass checked and 3 decimal places checked, and nothing else. Then you click OK. Then you go back to Analyze, and you go Set Scale, and you have to click to remove scale. Okay, and that lets you count pixels instead of, something else. Okay, now I'm going to go to Image, Adjust, Brightness and Contrast. And there's more than one way to do what I'm about to do, but it's got to be done. See how blurry those guys are? We're going to brighten it up and contrast it up. My goal is to make them kind of smaller and a jet black background. Now that jet black background is important because we're going to make these circles and we're going to find the center of gravity of all the light inside that circle. The jet black background is not jet black, and let's do a better size circle. If I go off to the side like right there, it'll work. And it'll find the center of gravity of that, or center mass of that, as long as that's jet black. But if that's not jet black, then having it off a little bit will draw it off. So I can make these circles, ellipses. I can click the square and I can make squares. I can make anything. On Bill's slit version of this, we do rectangles. On Bill's pinhole version and Lonnie's pinhole version, I like to use that guy there. Now, if I do that, notice that I'll get an ellipse of weird sizes and shapes. So what you could do is you can start your ellipse, put my crosshair in, click the button, hold the button down, and come down. I hold the shift button down. That keeps that round thing a perfect circle. Now I let go. Now it's a perfect circle. So we're going to nail all of these guys. Matter of fact, that one there is going to be nailed 4 times. I'm going to go all 15 of those, all 15 of those, all 15 of those, all 15 of those. This guy will actually get nailed 4 times. Now, order matters. 1, 2, 3, 4, 5, 6, 7, 8, 15. Then up here, 16 through 30. Then up here, 31 to 45. Then up here, 46 to 60. So here we go. Click and hold. M as in Mike. I'm still got my click down. I could drag it over. M, 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 M M, 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 M. It's probably good to have those guys dead center of circles. As long as the background is jet black, it shouldn't matter. M, 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 M. Order matters. And the instructions for the order is on the Easy Hartmann spreadsheet. M, 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 M. Now, in case I missed one or double tapped one, I also come back and look, make sure I got 60 of them, and I even go up and make sure they all have numbers. They all got numbers, so we're good. Now, in this same box here, I'm going to go File, Save As, and I'm going to go to the directory I want it in, which for me is Documents, Astronomy, ATM, Hartmann, AAU, that's the name of the mirror I'm working for some guys. And then this photograph number was 7510, so its name will be 7510. And that way, I can't go and grab the wrong image, which, boy, does that ruin your day. When you grab a wrong image, you're the wrong Excel file, and you stick it in, and you work the mirror based on a wrong file. It's like, duh. All right, I'm done with ImageJ. Wasn't that great? Now, what we just did, so we found the center of mass of all these dots to 1,000th of a pixel. And something you could try later on is you can try doing that in M, then doing that in M, and doing that in M. And you'll see that they're all within 1,000th of a pixel of each other. As long as the background is black, it is that dead, repeatable, accurate. It's remarkable. By the way, if you have one of these hanger holes, don't do that one. Okay, X that out and go bye-bye. Alrighty, we open up Lonnie's Easy Hartmann test, which looks like that. You can see the mess I've got in the middle of this mirror here. It's pissing me off. Okay, now that is up and running. By the way, when you first open it up, there's this thing here that says Enable Macros. You got to click it. I'm not going to turn off this thing and start it up again just to show you that, but right here will be an Enable Macros sign. You must click it. Okay, we're going to take those file numbers that we just got, and we're going to enter them right here. So I got to go get them first. So open. I go to my folder where I stuck those bad boys. And right there is 7510.xls. Click. The file format, blah, 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 doesn't match. The file can be corrupted and unsafe. Do you trust this? I do, because I do. And then it's like, just go next, next, and then finish. And now, there it is. So these are the 1 through 60s. This is the X coordinate, and this is the Y coordinate. We're going to highlight from that cell right there down to the end down there. Don't get any more, don't get any less. Copy that. Get rid of this. Do you want to use that on the clipboard? Duh, yeah. Okay, then we're going to go to that one right there and click right the spot right there. Now when I paste it, it just filled in that whole thing. Now, right there, at cell P3, I'm going to put in my exposure number, 7510. That just keeps the record going. Now, this updates the date for you. Now, if I open this thing up to see what the date was, it updates it again, so it doesn't do much good. So I like to keep track of this photo number. And I might make another cell somewhere along the way that does my date. I don't know. We'll see. Okay, so we got the data in. We got the photo number in. And here we go. Control X as in X-ray, and boom. Now what this does, I'm going to start with the astigmatisms first. This is my astigmatism chart. This is an old version. The new version does it by percentage. This one does it by pixel. So it takes the zone 7. There are 8 zone 7 holes. Hole 1 through 15 is the horizontal. Hole 16 through 30 is that diagonal. 31 and 45 is the vertical, and 46 and 60 are the other diagonal. It takes those 4 pixel distances and it computes the highest to the lowest, and then it says what the difference is. So the difference in those pixels for zone 7 is 2.891 pixels. Now we're talking thousands of pixels here. So originally Lonnie and I were going 6 pixels is tops, but try to get down to like 3 or 2. I believe his newest version has a percentage value, and we're going to want to talk to Lonnie about where we think the right percentage would be. The reason we're going to go to percentages, I have 5,905 pixels per inch. You might have 3,400 pixels per inch. So 6 pixels is different on your camera than it would be on my camera. So pixels is not a good one to use. Nonetheless, my numbers are 0 through 3, almost 4. I'm fairly acceptable on that. The one you want really small is zone 7 because it's the reference datum for the rest of the mirror. If you can get into the zeros, that's awesome. Alrighty, so these are, got a dog in my throat. These are 8 millichroigraphs. Here's a millichroigraph for range 1. That's the left-hand horizontal. Here's a millichroigraph for range 2. That's the upper left. Here's range 3, vertical top. Range 4, upper right. Range 5, lower right. Range 6. Range 5 is right horizontal. Range 6 is lower right. Range 7 is straight down. Range 8 is down and left. So 1 is opposite of 5. 2 is opposite of 6. 3 is opposite of 7. And 4 is opposite of 8. And so it's really nice to be able to use all 8 of these so you can do local work on spots without doing the entire mirror. And like you see this low thing here, it's nice to know that if all you had was the average graphs, you might say, I need to work zone 4 a little bit, but dude, that was already low. You don't want to go down on that. So it's nice to know the local issues. Alrighty, so if you look at this middle of my mirror, it's a piece of crap. I've been working on that. For some reason, it's not showing my last work. So let me zoom in on that just a little bit. Wrong way, stupid. Oh, yeah, it does. Okay. So the light blue dotted line was my last session, and the dark curve is my current session. So a person could say, oh, good, I was able to lower it down with the work I just did. And oh darn, it went up this time, and it went up this time, and it went down here and up there. So you can look at the progress of what you've done. Okay, so now that I've done this test, I save my test by calendar name. So my calendar name is year, month, day, 24-hour clock time. So that way when it sorts in the computer, it sorts them in order. Okay, now I got to go back and talk about setting up the test end. Do you remember when we set the Ronchi grading at 0, then we dialed it back? Well, on my mirror here, I needed to dial it back stage distance behind ROC. We're talking G6, cell G6. Cell F6 is the name of it, and cell G6 is the action. When I first did the Hartmann test on this mirror, I dialed it back to where I thought it was good, and I measured what that was. Then I had to go and, okay, it's a combination of dialing it back and adjusting the pinhole, dialing back and adjusting the pinhole until you get where you want. So since I dialed it back 0.938 inches, I had to make sure that that pinhole was 0.938 inches in front of that base plate. Now, I don't have to adjust anymore. I just do that every time. So every time I set up the test stand with the Ronchi grading at the 0 zones radius of curvature, I then dial it back 18 3/4 dials, and this number just stays in there, and I just keep using it. All right, so the blue cells get written in. Mirror diameter, it's a 22. How big is the chamfer? It's 0.035 inches. The radius of curvature, I measured it, is 197.063. And I had to dial that back 18 3/4 turns on a 20 thread deal here. Let me check my arithmetic on that. I got my calculator here. I got 18.75 divided by 20 is decimal 90375. So that's rounding off to 938. Okay, now this mask has half-inch holes. They don't all have half-inch holes, but we put it in. Now this right here, mask outside diameter is 21.625. I have Lonnie make my masks a hair smaller than the optical diameter. So when I get another 22 inch and they have a different size bevel, I don't have to make a new mask. Now, that's not going to be good on Bill's test, because Bill's test, the outer edge of the outside holes must match the optical diameter, the what's actually called the entrance pupil of the optic. I don't have to do that with this Hartmann test, nor on my at the focus Hartmann test. We don't have to do that. Okay, so once all that data is plugged in over here, the camera picture number is plugged in here, and these guys are plugged in right. That's when you do a Control X. Okay, now what you do to fix the mess you got here, that's another topic. But at least this is how to get the Hartmann test happening. A couple bells and whistles that are pretty cool here. I color-coded mine differently than Lonnie, so I'm not going to get into that. This is the average of all 8 ranges. And so this one here should match Bill's lit test pretty good. And historically, we have found that they match it exactly. Bill's lit test is crazy cool. This one here, when you average these zones, you get the same thing that you get on Bill's sit test or lit test. However, we have the benefit with this of saying, I got to go to range 1 and work on zone 6. And then I got to go to range 6 and work on zone 1. So this really spot checks the mirror. I'm going to go Control Q. That brings it down to this table, which Lonnie has made to do things with the Zambuto method of figuring zones. So I'm going to let him talk to you about that. I'm a learner on that. I'm going to do Control A. It takes me right back to the top again. And I don't know if there's anything else I need to show you on this. Oh, yeah. This is cool. My secondary mirror is this big. If you can watch my thing here. Okay, I'm going to do Shift Flag S. And my secondary mirror is that big. Notice it hides all the anomalies on my mirror. So this cell J15, if it's set to 0, it does all the zones. But if I were to change it to a 1, it's only going to do from zone 1 out. I hit an enter there. So notice it leveled those guys up, leveled those guys up, leveled those guys up, and leveled those guys up. Now, if I go 2, it does it from zone 2. So it never minds the stuff on the inside. It only gets the stuff on the outside. And I don't know why it didn't do that one there. I'm going to hit that again. I can explain. Anyway, notice it made the inner part that's disastrous go away. Now, the reason that's really good to do is as tall as these graphs are, it scrunches the graph down. But if you can do that to make the graphs shorter, if you Control X again, it will spread those graphs out. So here we go. You see how big that graph is there, how skinny it is? Control X. And boom, the graph is now bigger so we can see these details out here more easily. So that is a real good benefit. Now, from zone 2 to zone 7, the graph's exactly the same. So now I could do a better job analyzing what I got to do on these outer zones because the graph is spread out. And again, my secondary mirror is so big that it's actually going to be hiding the blemishes on the inside of the mirror anyway. I am by no means suggesting that you don't fix the inner areas. I'm just saying. Okay, so that was Lonnie's easy Hartmann test. And I'm sure we'll think of more stuff later, but I hope that this was a help to you. And just let me know if you need more. Adios.